All right. Written response number 9 here. Find the asymptotes of that expression and explain essentially why these are asymptotes. Okay, first we're going to look at the most obvious one here, and that's where the denominator is going to go to 0. Now, in order to really make sense of this, because I've got a quadratic in the numerator here, and you spent a fair bit of time in Math 30 talking about these points of discontinuity and whatnot. Notice that the degree of the numerator is actually going to be 1. Okay, so this is a degree 1 over a degree 1. So there's going to be none of that canceling that's going to lead to a point discontinuity. So essentially what we've got here in the denominator is we're going to get a vertical asymptote where x is equal to 4/3, because at x equals 4/3, the denominator, okay, because we have to explain what's going on here, the denominator is 0, giving an undefined result. Okay, now we can also do this a couple of other ways here. We know that the numerator is always going to be positive because a square root can only produce a positive result. So we could also explain this like this. If you take the limit as x approaches 4/3 from the left of our function, okay, the numerator is going to be positive, the denominator is going to approach 0, but it's going to approach 0 from a value that is slightly to the left of 0. It's going to be slightly negative. So that's going to approach negative infinity. And if we approach 4/3 from the right-hand side of the function, the denominator is slightly positive, and then the whole thing will approach positive infinity. So again, you're seeing this drop, and then it's going to be a slide up there to infinity. So there's where my asymptote's coming from. Now, horizontal asymptote. Okay. Now this is about comparing degrees. Okay, and if you allow the value of x to get infinitely large in either direction here, okay, we're going to just investigate what happens here. Now, again, notice that the numerator, okay, the numerator will always be positive. Okay, so the numerator is always positive. That's an important point to make here, and that's because of the square root. The square root can only produce positive results here. Okay, the numerator is always positive. And for large x, it is approximately, okay, for very large x. Now this is very large x in either the positive or the negative direction. If you just take a look at this, underneath the square root, the 16x squared becomes the dominant term, like this 9x minus 1. When you're talking into the billions for x, that really doesn't mean anything. So the dominant term here is the 16x squared. Under the square root means it's going to be approximately 4x. Okay? Okay. So the numerator is always positive. The numerator is approximately 4x, and so now when you compare the two dominant terms, the numerator and denominator here, that ratio, okay, therefore you're going to get this 4x over 3x, okay, approximately, which is going to equal 4 over 3. Okay, as long as obviously x does not go to 0, but that's not an issue because we're going really big here. Now that doesn't quite finish it here though, because the denominator is negative for values of x that are negative, like I guess you want to say large negatives, and positive for large positive values of x. Okay? Now, the reason I say that is because in this case right here, if you take the limit as x goes to positive infinity, the numerator is positive, the denominator is positive, so your horizontal asymptote will be 4/3. But if you take the limit as x goes to negative infinity, the numerator stays positive, the denominator goes negative, and so this becomes negative 4/3. And so those are your asymptotes, 4/3, negative 4/3, and then we've got that vertical asymptote at x equals 4/3. So a whole bunch of 4/3 happening everywhere.